Okay, students. Now, the first question is, what is the change in oxidation number of carbon in the following reaction? And the reaction is, methane is reacted with Cl2 gas to form CCl4 plus HCl. And reaction is free radical substitution reaction. Now, in this case, if we consider CH4, then hydrogen have less electronegativity as compared to carbon. Therefore, carbon will get -4 oxidation state due to these 4 bonds. And after reaction, it will convert into CCl4. And the electronegativity of chlorine is higher than that of carbon. It means these chlorine will get -1 oxidation state each, and this carbon will get +4 oxidation state. So in this case, change should be -4 to +4. Clear? So answer will be second.
Well, students, our question is, on electrolysis of dilute sulfuric acid using platinum electrode, the product obtained at the anode will be. Students, this question is from the electrochemistry chapter, class 12th. This is from the electrochemistry chapter, class 12th. And we have been asked that the product at the anode will be if we are electrolyzing dilute sulfuric acid. Now, student, the reaction at anode, we will be having two factors or two possibilities over there, that is the oxidation of SO4 minus or the oxidation of H2O. Students, for the oxidation of SO4 minus, the E0 value is -1.96 volt, and for the oxidation of water, the E0 value is -1.23 volt. The product at anode will be that which is having the higher value of SOP, that is standard oxidation potential. So higher oxidation potential is for water. So water will get oxidized over here, and the product at anode we will be getting oxygen. Clear? And water is also in the excess amount because we have been using dilute. So we can also clarify from that statement that if it is dilute, the water is in excess, so the product at anode will be from the water. So the oxidation of water is taking place, so the correct answer is answer number 1, that is oxygen gas will be liberated at anode. Our question is, an increase in the concentration of reactants of a reaction leads to the change in. Student, this question is from the chemical kinetics, class 12. This question is from chemical kinetics chapter, class 12, and it's saying that an increase in the concentration of reactant leads to of a reaction leads to change in. Now, student, if the concentration of the reactants is increased, that means moles per unit volume. Moles per unit volume will also increase. Moles per unit volume will also increase. If moles per unit volume is increasing, that is collisions will increase. Collisions will increase. Clear? Now, students, we know that the collision frequency is the number of collision happening in a unit volume in a unit time. So, if the concentration has been increased, the number of colliding particles will increase, and if the number of colliding particles per unit volume in a per unit second is increasing, so the collision frequency will be affected. Clear? So the correct option from this is option number 3. Clear?
Okay, students, let's discuss next question. The question is reaction between benzaldehyde and acetophenone in presence of dilute NaOHs. Now, what is benzaldehyde? Benzaldehyde is an aldehyde having 0 alpha hydrogen. Clear? And second one is acetophenone. What is acetophenone? It is a methyl ketone CH3COOPH having 3 alpha hydrogen. Now these two compounds are reacted with base NaOH. Clear? Now we know that if we react any carbonyl compound with base, then there is a possibility of two reactions. First one is aldol and second one is Cannizzaro. And the condition for aldol is presence of alpha hydrogen. And condition for Cannizzaro is absence of alpha hydrogen. Now in this case, one carbonyl compound is having alpha hydrogen, means Cannizzaro is not possible. This will show aldol reaction between two different compounds. That's why this aldol is known as cross aldol condensation. So in this case, answer will be third. Clear? Okay, students, coming to this next question. Which of the following alkane cannot be made in good yield by Wood's reaction? Now, first of all, what is Wood's reaction? Wood's reaction is a reaction of alkyl halide with sodium to form a symmetrical alkane, that is RR plus NaX. Clear? Now in this case, we know that Wood's reaction is used for the formation of symmetrical alkane having even number of carbon atoms. Now, if we check the option, first is 2,3-dimethylbutane. The structure of 2,3-dimethylbutane is this. Now, we can divide it into two equal parts, means it can be formed by this halide and this halide, means this is formed by CH3, CH3X. This halide is used to form 2,3-dimethylbutane in Wood's reaction. Second one is N-heptane. N-heptane, hept means total 7 carbon, means odd number of carbon atoms, and we know that in Wood's reaction only alkane having even number of carbon atoms can be formed in good yield. So in this case answer will be second. N-butane, it can also be divided into two equal parts, that is ethyl, means it will be formed by ethyl halide. Ethyl halide react with sodium to form C2H5, that is N-butane. Last one, N-hexane, it is also symmetrical alkane formed by propyl halide, that is N-propyl halide on reacted with sodium will give us N-hexane. Clear? So first, third, fourth, these three alkanes can be formed in good yield by Wood's reaction, but second cannot prepared. So answer is second. Clear? Students, coming to the next question, which the following is a natural polymer. Now, if we consider polybutadiene styrene, then it is known as Buna S, that is a synthetic rubber. Clear? Second one is polybutadiene, it is also a polymer of butadiene and it is also a synthetic rubber. And third one, polybutadiene acrylonitrile, also known as PAN, it is also a synthetic polymer, also known as Orlon. And last one, cis-1 for polyisoprene, that is the name of natural rubber formed by cis form of polyisopropene. Clear? So in this case answer will be fourth. Clear?
Our question is, a mixture of N2 and argon gases in a cylinder contains 7 grams of N2. We have been given the weight of N2 is 7 grams and 8 grams of argon in it. If the total pressure of the mixture of the gases in the cylinder is 27 bar, we have been given the total pressure of the gaseous cylinder is 27 bar, then we have to calculate the partial pressure of N2. Now students, we all know that for calculating the partial pressure, we have to know the mole fraction of it. So the formula for the partial pressure is mole fraction into total pressure, and the mole fraction will be of N2. So for calculating the mole fraction of N2, we have to know the moles of nitrogen and moles of argon. So the moles of N2 will be, this will be 7 by 28, this will be equals to 1 by 4, and the moles of argon, this will be equals to 8 by atomic weight of argon is 40, so this comes out to be 1 by 5, so this will be 0.2 and this will be equals to 0.25. Substituting the values in this particular equation, this will give pressure of N2 will be equals to the mole fraction of N2, this is moles of N2, that is 0.25 divided by 0.25 plus 0.2 into, this is total pressure has been given in the question, that is 27 bar. So this will be equals to 0.25 divided by 0.45 into 27. Point has been removed from this, so this will be equals to, after solving this comes out to be equals to 5 by 9 into 27, so this will be equals to 3, so 5 3s are 15. So the correct partial pressure of nitrogen in this mixture will be 15 bar. Clear? So the correct answer is answer number 2, that is 15 bar.
Question, this question is asking that match the following and identify the correct options. Actually, you must know that the CO plus H2, carbon monoxide and hydrogen, both of these combine to make here a syn gas, water gas or synthetic gas. So for A, we can say that the third option is going to be correct here. For A, third option is going to be correct here. Obviously, third option is not possible here. Next, temporary hardness of water. Water can be hard and the hardness are of two types, temporary and the permanent. Temporary is caused by the bicarbonate of calcium and magnesium, while the permanent by the chloride and the sulfate of calcium and the magnesium. Right now it is asking about the temporary hardness. So obviously we can say that the magnesium and the calcium bicarbonate. It means for the B, first option is going to be correct here. So for B, first option is going to be correct here. B second, B4 are not possible here. Next, B2S6 Diborane. Student, this is the structure and you can see that this is the banana bond. And here we are having 1, 2, 3. This is going to be called here the 3-center 2-electron bond. If you are calculating here the number of electron in the boron, then you come to know that 1, 2, 3, 4, 5 and the 6 electron are present here. Incomplete octet, it means we may call it that electron deficient hydride. Electron deficient hydride. So for C, second option is going to be perfect here. For C, second is going to be perfect here. Next, H2O2, hydrogen peroxide. This is the structure. And because of presence of lone pair, this is not planar. This is not planar. The open book-like structure is there. This is kind of the open book-like structure. Open book-like structure, and this is not planar structure. For H2O2, we can say that non-planar structure due to presence of lone pair on oxygen. So for D, we are having at the fourth. Obviously, we can say fourth option is correct for you. Thank you.
A question is, for the reaction 2Cl gives Cl2 gas, 2Cl gas gives Cl2 gas, the correct option is. Student, this question is from the thermodynamics chapter, class 11, and I have been given the reaction that is 2Cl2 Cl2. Students, in this particular reaction, the moles of reactant is 2. We are having 2 moles of reactant and the mole of product is 1. So 2 moles is being converted into 1 mole. 2 mole has been converted into 1 mole. So randomness will be decreased. Randomness will be decreased. And if the randomness is decreased, entropy will also be decreased. So entropy will also be decreased. So if the randomness is decreased, entropy is decreased, that is delta S will be less than 0. Clear? Now moving on to enthalpy, that is delta H. Students, in this particular equation, 2 atoms are combining to form a molecule. If 2 atoms combine, the energy will overall be released because atoms are combining, they are colliding. So the energy will be released, that is, this will be an exothermic reaction, that is delta H will be less than 0. Delta H will be less than 0, and if delta H is less than 0 and delta S is also less than 0, so the correct option will be option number 3, that is delta H is less than 0 and delta S is also less than 0. Clear? And the answer is answer number 3. Our question is, an element has a body-centered cubic structure, that is BCC structure, with a cell edge of 288 picometers. So the atomic radius is. Now students, we have been given a BCC structure, and in BCC structure the atoms are present at the corners as well as the body center. Atoms are present at the corners as well as at the body center. So if we are having an edge length of A, so the body diagonal, the length of the body diagonal, this will be equals to root 3a by Pythagoras theorem. This A is outside the root. So by Pythagoras theorem, the value of the edge, body diagonal will be equals to root 3a. Now this particular root 3a will be equals to r plus, this is 2r and this is equals to r. So this root 3a will be equals to 4r, r plus 2r plus r. So the relation between the edge length and the radius will be equals to root 3a equals to 4r. Now students, we have been given the edge length, that is 288 picometer. We just have to substitute this value in this particular equation and we can calculate the atomic radius out of it. So this will be, the value of r will be equals to, this is root 3 by 4 into a, and that is root 3 by 4 into the edge length has been given, that is 288 picometer. The question is very easy because in this particular question they have also not used any calculation, they have just given the relation. Clear? So the correct relation this will be root 3 by 4 into 288 picometer. That is answer number 4. Clear?
Krishna, this question is asking that urea reacts with water to form A. This is the formula of urea, NH2CO, NH2. Nitrogen is having the lone pair. Because of that, it works as the Lewis base. While treating with the water, you can see that will be the decomposition, HOH. We will get here the ammonia and CO2 and the ammonia. Because water is present here, so obviously we can say that the ammonia and the water will combine to form here ammonium hydroxide. So ammonium hydroxide we are getting, this is the compound A, and this will decompose in compound B. A will decompose to form what? Compound B, and B when passed through the copper aqueous, you can see that B compound is the ammonia. We are passing this ammonia in the aqueous copper. So you can see that we are getting the tetraamine copper, and here the color is blue. Which blue? It is mentioned here, this is the deep blue color. Deep blue color. So student, one more thing, we can also write here the copper aqueous in such way that tetra aqua copper ion while passing ammonia, because the ammonia is working as a strong field ligand while the water is weak field ligand. So ammonia can displace here the water molecule. We are getting here the tetraamine copper ion. Student, this is deep blue in color. So we can write in the either way aqueous copper or copper aqueous, because you can see that the ammonia is making here the complex. Which complex? Deep blue color complex with the copper. Obviously we can say that the first option is going to be correct here. Thank you.
Okay students, coming to the next question. The question is, a reaction between acetone and methyl magnesium chloride followed by hydrolysis give. Means it is a reaction of carbonyl compound, that is acetone, with Grignard reagent, that is a source of nucleophile, that is CH3 MgCl. So in this case, reaction will be nucleophilic addition reaction. Now in this case, this CH3 will attack as a nucleophile on this carbon to break this pi bond and form the addition product, that is CH3C, CH3, CH3, O minus and MgCl positive. Now after hydrolysis, this O minus will abstract hydrogen from this water to form the final product, that is CH3 and 1OH, that is an alcohol, and the name of this alcohol is tertiary butyl alcohol. So in this case, answer will be second. Clear?
This question is asking that the following metal ion activates many enzymes, participates in the oxidation of glucose to produce ATP, adenosine triphosphate, and with the sodium is responsible for the transmission of nerve signal. This is taken from the NCERT of S block element. You can see that as far as the new NCERT is concerned, you will get this at the page number 306, while in old NCERT, the page number is 298. The topic is biological importance of sodium and the potassium, and you are getting that information that potassium ions, these are the most abundant ion within the cell fluid. As far as the glucose is concerned, some enzyme you can see that will oxidize this glucose into ATP, adenosine triphosphate, and here K plus ion will activate these enzymes. So we can say that yes, potassium ion are those which are working here to activate enzyme. Third option is going to be correct here, potassium metal. Thank you.
Question is, the number of protons, neutrons and electrons in Lu 71, 175 respectively are. Students, this question is from atomic structure or the structure of atom. Clear? Now student, for a general element, the representation is as follows: X, this is Z and this is A. This is atomic number, this is atomic number, and this is mass number, and this is mass number. So atomic number is equals to number of electron, which is equals to number of proton, and mass number, this is equals to number of proton plus number of neutron plus number of neutron. Clear? So we can easily calculate the number of electron and number of proton by just looking at the atomic number of this particular element. Clear? And for calculating the number of neutrons in it, we will subtract atomic number by its mass number. So students, let's start. This is Lu 7175. So this 71 represents the number of electron and number of protons. So electrons will be equals to 71, protons will be equals to again 71, and neutrons will be equals to 175 minus 71. This will be equals to 104. Clear? So we have been asked about proton first, then neutron, and then electron. So the protons will be 71, protons will be 71. The second is neutrons. This is neutron is 104, and the last one is electron. This is again 71. So the correct relation, the correct series will be 71, 104, and 71. And the answer is answer number 4. That is 71, 104, and 71. Clear? So the answer is answer number 4.
This question is asking that which of the following set of molecule will have a zero dipole moment? Actually, we can see that the question is asking that the molecule must be non-polar. Non-polar. And those molecules which are planar, like we can say BF3, boron trifluoride, and the direction of polarity is towards free fluorine. So resultant dipole moment equals to was 0. Though the bond is polar, but the molecule is non-polar. Next, BeCl2. Again, we are getting here the planar structure. And overall dipole moment equals to 0. Non-polar molecule. Same yesterday, both of beryllium as well as the carbon are showing here the sp hybridization. No any lone pair is present on the carbon. We are getting here the linear structure. Linear structure. So again, dipole moment equals to 0. Non-polar structure. You can see here benzene is also planar, and here we are getting the direction of polarity, and the angle we are getting here of 180 degree. Because of that, it becomes again non-polar. Why? Because the polarity of these two bonds is cancelled by each other at 180 degree angle. Actually, this question is taken from the chemical bonding topic and the molecular structure of 11th class NCERT. And you can see that in the first option, hydrogen fluoride, this is polar. This is polar. Next to 1,3-dichlorobenzene, you can see student 1,4-dichlorobenzene, and this is the 1,3-dichlorobenzene. Student, here dipole moment not equals to 0. This is the polar molecule. This is again a polar molecule. So we can say that first option is not possible because of presence of these two examples. Next, nitrogen trifluoride. Student, NF3, nitrogen having one lone pair. The pyramidal structure is formed here. So we can see that the direction is towards lone pair. Here we are having the direction towards the fluorine of polarity. So dipole moment is not possible here to be 0, non-zero. Polar molecule. Next, not possible here. As far as water is concerned, student, this is also a polar molecule. And you can see that oxygen is getting here the delta plus charge, while the water hydrogen atom in this water molecule are getting here the delta plus charge. Polar molecule. So not possible here. Boron trifluoride, first option. Barium difluoride, this is the structure. Carbon dioxide and benzene 1,4-dichloride, or we can say that 1,4-dichlorobenzene. Yes, this is the option which is showing here the non-polarity. So third option is going to be correct here because of presence of ammonia. It's not like this NF3 pyramidal structure is formed here. Because of that, it is not going to be non-polar. This is a polar molecule. This is truly a polar molecule. So we can say that only third option is correct for you. Hopefully you done so. Thank you. This question is asking that identify a molecule which does not exist. It means the bond order should be 0. Bond order should be what? 0. And you can see that the diatomic species are given here. So we will apply here the MOT, molecular orbital theory. So it says that the bond order equals to the NB minus NA divided by 2. It means NB before the BMO, bonding molecular orbital. Electron in BMO, Na, electron in anti-bonding molecular orbital. So first of all, we are having the example Li2. So lithium atomic number 3, 2 lithium, it means the 6 electron are there. 2 carbon, 12 electron, total electron. 2 2 oxygen, 16 electron, He2, 4 electron are there, got it? And we are writing here the electronic configuration based on which theory? Molecular orbital theory. Ishwan, this is the question based on chemical bonding, and the topic is molecular orbital theory. Good. So now you can see that we are having the configuration sigma 1s2, sigma star 1s2 and sigma 2s2. So 2 plus 2, 4 electron in the BMO, while sigma star, it means what? 2 electron in ABMO. So we are getting here the bond order 1. It means this is going to exist here. So this is not your answer because we want here does not exist. Next, we are writing here the carbon. KK. Student, you can see that first shell, we can also write here the first shell's configuration like this KK. Got it? Next, second shell, sigma 2s2. This is the configuration of the carbon. You can see that electron. If we are excluding this, then we are getting here the configuration of 2 plus 2 plus 2, 6 electron in the BMO, while star, it means the 2 electron in ABMO. 6 minus 2, 4 by 2, it means the 2 is the bond order. So we are getting here the C double bond C, Li single bond Li. This is a sigma, but you must know that both of these are the pi bonds. Next, we are getting O2, obviously very common strand. 2 is the bond order, one sigma, another one is the pi. Next, helium. This is your answer, friend. You can see that 4 electron are there, sigma 1s2, sigma star 1s2. So bonding minus anti-bonding, 2 minus 2 equals to 0. So bond order is 0 for He2. This is going to be non-existing. Rest of these all are existing here. Thank you. This question is asking that identify the incorrect match, wrong match. You can see said that some IUPAC name of elements are given here. This question is based on the chapter classification of elements and periodicity in the properties. And you will get, as far as NCERT is concerned, one table is given at the page number 76 or 77. This is the new NCERT. Now, student, you can see that IUPAC technique says that for 0, we will use here the nil, 1, un, 2, bi, 3, tri, 4, quad, 5, pent, 6, hex, 7, sept, 8 oct, and for the 9 we will use here the n. So the name is unilanium 101. This is Mendelevium and the symbol is MD. This is the correct. This is going to be a correct. Next, whenever we study the actinoids, so Mendelevium is coming in that. Next, uniltrium, it means 103 is the atomic number. This is the atomic number. Yes. This is the last actinoid, Laurentium, and the symbol is Lr. Next one, unilhaxium, 106 is the atomic number, and the element is Cborgium, Sg is the symbol. Yes, of course, this is belonging to this category. Atomic number is 6. Perfect here. We want here the incorrect match. Next is the unanium. It means 111. This is the atomic number. And the name is given here the Durham Stadium. Student, this is going to be wrong here. As far as the Durham Stadium is concerned, this is the symbol DS. And its atomic number is 110. It is given here the 111. So the name should be here the unhelium. This should be the name, unhelium. Un for the 1, that's 1, and helium for the 0, 110. So we can say that D4 option is going to be wrong here, and that is your answer. D4 is wrong option here. So we can say that third option is going to be correct here. Option is correct, but the match is incorrect here. Thank you.
Students, our question is the rate constant for a first order reaction is this much, 4.6 into 10 to the power of minus 3 second inverse. The time required to reduce 2 gram of reactant to 0.2 gram. So we have to calculate the time required for this conversion. Clear? Now student, as this is a first order reaction, and for first order reaction, we know that K is equals to 2.303 by T log of A0 by 80. This is the relation. And we have to calculate the time, and we have been given the value of rate constant, that is 4.6 into 10 to the power of minus 3. So time from this will be 2.3 0.03 divided by 4.6 into 10 to the power of minus 3 into log of, this is 2 gram initial concentration and the final concentration is, students, 0.2 grams. After cutting this comes out to be equals to 10, and the value of log 10 is equals to 1. Value of log 10 is 1. So time period from this will be equals to, this can be calculated out, this will be equals to 2. 10 to the power of minus 3 will go up, this will be equals to 10 to the power of 3 divided by 2, this will be equals to 500 second, that is 1000 by 2, which will be equals to 500 seconds. So for the conversion of 2 grams to 0.2 gram, 500 seconds will be required. So the correct answer will be answer number 2. Clear?
Which one? This question is taken from the general principle and the process of isolation of element. In short, we may call it the metallurgy. So the question is said that identify the correct statement from the following. First, blister copper has the blister appearance due to evaluation of carbon dioxide. Student, this is the wrong option. The gas is a sulfur dioxide. How can we say? Because there is a process happening in the Bessemer converter and famously known as Bessemerization, in which cuprous oxide and the cuprous sulfide are treated, and this is the auto reduction reaction. So you can see that sulfur is combining with the oxygen to form sulfur dioxide. This is evolved, got it? And we are getting here the copper, reduced copper. This is the blister copper, and the blister appearance is due to evolution of sulfur dioxide, not carbon dioxide. So this is going to be a wrong statement. We want here the correct. So cross it. Next, vapor phase refining is carried out for nickel by Van Orkel method. As far as the vapor phase refining is concerned, we are having the two techniques. One is the Mond process, next one is the Van Orkel. For Mond process, we are using here the metal nickel. For nickel, we are using here the Mond process. You can see that the carbon monoxide is the reagent here. If we are having the impure nickel, then the CO is passed. In this, we are getting here the compound, volatile compound, tetracarbonyl nickel. On further heating, it will convert into the pure nickel and the carbon monoxide. This is the Mond process. So Van Orkel method cannot be used for the nickel here. So cross it. Wrong option. As far as the Van Orkel is concerned, for titanium, zirconium, hafnium, all of these are belonging to same group, and we are using here the reagent iodine. We will get here this volatile complex. On further heating, again we are getting the pure metal and the iodine. So wrong option here. Next, pig iron can be molded into a variety of shapes. Yes, student, as far as the metallurgy of iron is concerned, at the last it is written here in the NCERT. This is the correct statement. Yes, we can mold pig iron into the different kind of shapes. But 4 option is again wrong. Why? Because the wrought iron is impure iron with 4% carbon. As far as the 4% carbon is concerned, this is the identity of the pig iron, not wrought iron. This is the purest form. So we can say that 4th option is incorrect. Only we can say that correct option is the 3rd for you. Thank you.
Our question is, measuring zeta potential is useful in determining which property of the colloidal solution. Students, this question is from the surface chemistry chapter, class 12. First of all, what is zeta potential? Students, if you are having FeOH whole thrice sol, and if we mix FeCl3 in this, positive charge will get adsorbed on the surface. And seeing this, the negative charge will also come over here. Now students, this is the first layer. That is the positive layer, positive part layer. This is known as fixed layer. This is fixed layer. And this negative part, this will be diffused layer, because it has come after seeing this positive charge. So this is diffused layer. This is a diffused layer. Now student, a potential difference is created between these two layers, and which is known as zeta potential. The potential difference between these two layer or a double layer is known as zeta potential. Now students, greater the zeta potential, greater will be its stability. Greater the zeta potential, greater will be its stability. So increase in zeta potential will give the increase in stability, or decrease in zeta potential will give decrease in the stability. So zeta potential is the measurement of the stability of the colloid. That is option number 2.
Christian, this question is taken from the P block elements of 12th class, and the topic is oxo acids of sulfur. And you can see that which of the following oxo acid of sulfur has peroxide linkage. This is called here the peroxide linkage. First, H2SO4, sulfuric acid. This is the structure. You can see that peroxide linkage is not possible here. Next, H2S2O7, pyrosulfuric acid. This is the structure. You can see that SOS bond is present here. Peroxide linkage is not present here. H2SO3, sulfurous acid, one lone pair is present on the sulfur. H2SO3, peroxide linkage is not present here. H1, as far as H2S2O8, peroxodisulfuric acid is concerned, you can see that this is the peroxide bond which is asked in the question. Yes, peroxide bond is present here in the second option. Peroxodisulfuric acid is the correct answer. Thank you.
Okay students, coming to the next question. Now the question is elimination reaction of 2-bromopentane to form pen-2-ene. Now what is 2-bromopentane? That is CH3CH Br CH2 CH2 CH3. It will converted into pent-2-ene, that is CH3 CH double CH single CH2 CH3. So is a reaction E2 elimination. Now in this case the base is not given, so we have to check that is a Sedzov or Hoffman according to the product stability. Now in this case this carbon is alpha and this is beta and this one is also beta. Now if we remove hydrogen from this beta position, then this product is formed, and if we remove hydrogen from this position, then the product form will be CH2 CH CH2 CH2. This is pent-1-ene. Now from these two compounds, pent-1-ene and pent-2-ene, pent-2-ene is more stable, that's why it is known as Sedzov product, and this is also known as Hoffman product. So in this case the product form is Hoffman, and reaction is known as removal of hydrogen, bromine and hydrogen, means dehydrohalogenation. So in this case, first this is example of beta elimination, correct? Second, follow Sedzov rule, absolutely correct. Third, dehydrohalogenation, absolutely correct. Dehydration, no, because no water molecule is eliminated, that's why it cannot be considered as dehydration reaction. So in this case answer will be A, B and C, means option number 4. Clear?
This question is asking that identify the correct statement from the following. First, CO2 gas, carbon dioxide in the gaseous form, is used as a refrigerant for ice cream and the frozen food. This is the wrong statement. This is not the gaseous phase. CO2 in the solid phase, that is the dry ice, CO2 in the solid phase is used as a refrigerant for the ice cream and the frozen food. So the gas word is wrong here. We want here the correct. This is going to be now incorrect option. Next, the structure of carbon 60 contains the 12 6 carbon ring. It means the hexagonal, and 25 5 carbon ring, 25 carbon ring. This is again a wrong option. Why? Because the full ring in which carbon 60 is there, in which hexagonal 6-member ring are 20, while the pentagonal 5-member ring are 12 here. So 25-member rings are not present here. Again we can say this is the wrong option. Next one, ZSM5, a type of the zeolite, is used to convert the alcohol into gasoline. Yes, perfect. Ethanol is that alcohol which is converted into gasoline, also known as the petrol, and we are using here the ZSM5, which is the ZSM5. Got it? So correct option, yes, of course. Next, D, CO is colorless and odorless. Perfect option. We can say that both of these, means C and D are the correct here. It means third option is going to be perfect for you. Thank you.
Okay students, coming to the next question. An alkene or onolysis give methanol as one of the product. Its structure is. Now, there are two methods. We can form the products of all the 4 options, then find out in which case methanol is formed. Or second, if we think about general method, just suppose we have an alkene C double bond C and we don't know about these 4 valencies. And after ozonolysis, we know that we have to break this pi bond, double bond and add oxygen on both sides to form carbonyl compounds. Now, if I consider that this is methanol, means these 2 valencies, this one and this one should be hydrogen, means the alkene structure should be like this, C double CH2, means a terminal alkene. So in this case, the terminal alkane is present only in second option. So answer is second. Clear?
Ishwan, this question is asking that the paper chromatography is an example of. Ishwan, this question is taken from the organic chemistry chapter, organic chemistry, some basic principles and the techniques present in the 11th class NCERT. As far as the page number is concerned, in the old NCERT 353, while in the new NCERT 362 page number is there. Actually, different kind of chromatography techniques are there, like the partition, thin layer, column and the adsorption. But paper chromatography is belonging to this category first. Partition chromatography is the perfect word. Obviously, rest of these are not possible. First option is correct here. Thank you. This question is taken from 11th class NCERT. The chapter is the classification of elements and periodicity in properties. In short, we are calling this the periodic table. Got it? And the topic is periodic trends and chemical reactivity. This is the last topic of the chapter. So as far as NCERT is concerned, the page number is 94 in the new NCERT, but this is the 91 in the old NCERT. And the question is asking that the match the following. Some oxides are given here. We are supposed to identify here the nature of these oxides. It's one carbon monoxide. Carbon dioxide is acidic in nature, while the carbon monoxide is neutral. So you can match it. For A is the neutral. For A, we are writing at the second. For A, second is the perfect option. Obviously, you can see that rest of these are not possible. Next, BaO. Metal oxides are basic in nature. So we can see that first option is going to be correct for the B. For B, first is the correct. Yes, of course. Next, Al2O3. Though beryllium and the aluminium and the zinc, beryllium, aluminium and zinc are the metal, but their oxides are considered as the amphoteric in nature. It means these are showing the both acidic as well as the basic properties. So Al2O3 is amphoteric. Fourth option is going to be correct for this, C4. Perfect option. Next, Cl2O7. If metal oxides are basic in nature, so the chlorine is the non-metal. Non-metal oxides are acidic in nature. So Cl2O7 acidic, third option. For D, third option. It means we can say first option is correct here. Thank you, Shen.
The question is, which one of the following has maximum number of atoms? Student, this question is from the mole concept chapter or some basic concepts of chemistry chapter, that is chapter number 1 of class 11. So we have to calculate the maximum number of atom and we have been given the weight for this. First of all, we'll calculate the moles out of it and then we can calculate the number of atoms present. So for the first option, that is for magnesium, so moles of magnesium will be equals to 1 divided by its atomic weight, this is 24. In the second case, students, the moles of oxygen, this will be equals to 1 divided, and the atomic weight of oxygen, this is over 32, so this the moles will be 1 by 32. In the third case, students, this is moles of lithium, this is 1 divided by its atomic weight, that is 7. And in the last case, student, this is 1 moles of silver, that is Ag, this will be 1 divided by 108. Clear? Now students, we have calculated the moles. We can calculate the number of atoms easily out of it. So number of atoms, this will be equals to, in this particular case, moles into Na into atomicity, and atomicity is 1 over here. So this will be Na by 24. Na by 24. In this particular case, students, O2 is a molecule and not an atom. So this will be 1 by 32 into Na into 2 because in a O2 molecule we are having 2 atoms of oxygen. So this will be Na by 16. This will be Na by 16. Clear? In the third case, student, this is again an atomic form only. So number of atoms will be equals to 1 by 7 into Na. So this will be equals to Na by 7. This will be equals to Na by 7. And in the last case, silver is again an atom. So this will be 1 upon 108 into Na. This will be equals to Na divided by 108. Clear? So students, we have calculated the number of atoms and we have to calculate the maximum atoms, which the one which is having the least denominator will be having the maximum number of atoms, and the least denominator is for lithium because this is least amongst all. So this will be having the maximum number of atoms, that is option number 3, 1 gram of lithium. Clear?
Okay students, coming to the next question. Now the question is, which of the following is a basic amino acid? Now in this case, what is an amino acid? It's a compound having carboxylic acid and an NH2 group on its alpha position, and here the group is R. Now we can divide this in three parts, that is neutral amino acids, basic amino acids and acidic amino acids. Depends upon the number of acidic and basic groups. If acidic and basic groups are same, then it is considered as neutral, and if basic groups are more, then it is considered as basic amino acid, and if acidic groups are more, then it is considered as acidic. Now in this case, if we consider alanine, then the structure R will be CH3, that does not have any acidic or basic group, means this is a neutral amino acid. Second one is tyrosine. What is this? Tyrosine is COH, C6H4, CH2. If R group is this, then it is known as tyrosine. In this case, there is no basic group present. That's why it is also not considered as a basic amino acids. Third one is lysine. Lysine is considered as, if R group is NH2 and CH2 4 times, then it is known as lysine. Now in this case, this one is amino group, that is a basic group. That's why it is known as basic amino acid, means answer will be third. Now why we are considering only R group? Because in the remaining part there is one acidic and there is one basic, so both of them are equal. So we have to check in R that either it is basic or acidic. Clear? Last one, serine. Serine is OH CH2. Clear? If R is CH2OH, means hydroxymethyl, then it is considered as serine. Now in this case, there is no basic group present in this group, therefore it is also not considered as basic amino acid. So only answer in this case is third. Clear?
Vision, this question is asking that the calculated spin only magnetic moment of Cr+2 ion is. Spin only magnetic moment is represented by the mu b, and the formula is under root n into n+2. Here n equals to number of unpaired electron and the unit is bm, Bohr magneton. As far as the chromium is concerned, the atomic number is 24 and this is the configuration of chromium. Argon 4s1 3d5. So after removal of 2 electron, it will get here the +2 charge, and the configuration will be 4s0 3d4. It means if you are writing here the d4 configuration, so 1 2 3 4 unpaired electrons are present here. So right now the value of the n is 4. While putting this value in this formula, you are getting under root 25. Of course, under root 25 is 5, because of that under root 24 is slightly less than 5. It means 4.9 Bohr magneton is going to be the perfect answer. That is your option first. Thank you.
Okay students, coming to the next question. Now question is sucrose on hydrolysis give. Now the formation of sucrose is, it is formed by two monomeric unit, that is alpha D glucose and beta D fructose. This disaccharides is formed by these two monosaccharides. So on hydrolysis it will also give these two hydrolysis, alpha D glucose and beta D fructose. Now if we have to check the reference, then we can see that in NCERT on page number 409 on old NCERT books and 417 in new NCERT books, and chapter is biomolecules. Clear?
Students, our question is the mixture which shows positive deviation from the Raoult's law. Students, this question is from the solution chapter, that is of class 12. This is from the solution chapter of class 12, and we have to identify which of these will show the positive deviation. The first is students benzene and toluene. Benzene and toluene, student, it is an example of ideal solution. So this is an example of ideal solution. So it won't show any type of deviation, neither positive nor negative. The second is student acetone plus chloroform. Students, when we mix acetone and chloroform, hydrogen bonds are formed over there. Hydrogen bonds are formed over there, and if hydrogen bonds are formed, the vapor pressure will decrease. If you are mixing acetone and chloroform, hydrogen bonds will be formed and the vapor pressure will decrease, and this is an example of negative deviation. This is an example of negative deviation. The third point, student, this is chloroethane and bromoethane. Again, this is an example of ideal solution, so this won't be showing any type of deviation. This is again an example of ideal solution. So we are having the only one option left, so this will be our option. And for explaining this particular case, this is ethanol and acetone. Students, if you are having ethanol, it will be having hydrogen bond with another ethanol molecule, Now, if we mix acetone in it, hydrogen bond between these ethanol molecules will be broken, and if hydrogen bonds are broken, more and more molecules will go into the vapor phase. More and more molecules will be entering into the vapor phase, so the vapor pressure will increase. So it is an example of positive deviation. This is an example of positive deviation, that is option number 4. Clear?
Okay students, coming to the next question. Now the question is, a tertiary butyl carbocation is more stable than a secondary butyl carbocation because of which of the following? Now what is tertiary butyl cation? It is CH3 positive. This is tertiary butyl carbocation, and second is secondary butyl carbocation. The structure of secondary butyl cation is this. Now we have to compare the stability of these two cations. First of all, now both carbocations are saturated carbocations, means there is no difference in electronegativity. And second factor is resonance. None of them can participate in resonance because there is no conjugation in these both carbocations. Third factor is hyperconjugation. Now in this case, this carbocation is having total 3 plus 3 6 3 9, means total 9 alpha hydrogens, and in this case it have only 3 plus 2, that is 5 alpha hydrogen. No, we know that stability is directly proportional to number of alpha hydrogen, therefore tertiary butyl cation is more stable as compared to secondary. Now the statement is tertiary butyl carbocation is more stable than secondary butyl carbocation. True. Because of which of the following? What is the reason? Reason is only hyperconjugation. So in this case, answer will be third. Clear?
Students, our question is, find out the solubility of NiOH whole twice in 0.1 molar NaOH, given that the ionic product of NiOH whole twice is 2 into 10 to the power of minus 15. Student, this question is from Ionic Equilibrium chapter, and it's a very easy question. Because if we are mixing NiOH in NiOH whole twice, now student, NiOH whole twice, we have been given the ionic product for this. So it is a sparingly soluble salt because the ionic product, that is Ksp, for this is very, very less. So it is a sparingly soluble salt, and NaOH is a fairly soluble salt. Clear? So NiOH whole twice will ionize into Ni2 plus and 2OH minus. Let the solubility for this is S, so this will be 2S, and NaOH will ionize into Na plus and OH minus. So the solubility of this is 0.1 molar, which has been given in the question, and this one is 0.1 molar again. Clear? And this particular reaction is undergoing in a container. So OH minus will be a common ion over here. So the solubility of NiOH whole twice will decrease according to the Le Chatelier's principle, because if we are having a common ion over here, the reaction will move backward and the solubility will decrease. Now the new solubility of, let's say the new solubility of NiOH whole twice is Ni. First of all, the reaction for this will be this. So the new solubility, I am writing it as S dash. So this will be, students, S dash 2S dash plus C. This will be equals to 2S dash plus C. Now student, as the KSP value is very less, that is 2 into 10 to the power of minus 15. The value of KSP is very less, so the solubility will be in fact very less. So we can neglect this. We can neglect this. Clear? So if we can neglect this, so now student, if you are having a common ion effect, it won't affect KSP for the, it won't be affecting KSP because KSP is affected by temperature only. So the value of KSP will be same as before. So this will be equals to S dash into C square. This will be, I can write it as S dash to the power of 1 because stoichiometry is 1 into C square, and KSP has been given, this is 2 into 10 to the power of minus 15, which is equals to S dash. We have to calculate that, and C concentration for this has been given, this is 0.1 molar, this is 0.1 molar square. So S dash from here comes out to be equals to 2 into 10 to the power of minus 15 divided by 10 to the power of minus 2. This is equals to 2 into 10 to the power of minus 13. So the correct option will be option number 4, that is 2 into 10 to the power of minus 13. Clear?
This question is taken from the chapter Chemistry in Everyday Life, and the question is asking that which of the following is a cationic detergent. Those detergents are considered as a cationic detergent in which the carbon chain is bonded by the positive part. Positive. Cation means the positive part of that detergent. And this question is taken from the NCERT as far as the page number is concerned, old NCERT 452 and the new NCERT 460. First option, sodium state. This is the formula of soap, not detergent. And this is the formula C17H35COO minus and Na plus. So sodium or the potassium salt of higher carboxylic acids are considered as soap, not detergent. Cross it. Next, cetyl trimethyl ammonium bromide. This is the formula, and you can see that the positive part is the carbon chain is bonded by the positive part. Yes, of course, this is the cationic detergent, and this is your answer. Cetyl 1, 2, 3, trimethyl ammonium, nitrogen having plus charge, ammonium bromide, Br minus. Yes, this is the cationic detergent and your answer. Next is the sodium dodecyl benzene sulfonate. Sodium dodecyl for the 12 carbon chain, benzene sulfonate, and student, this is the anionic. How can we say? Because plus and the minus part. The carbon chain is bonded by the negative part, because of that is going to be called here the anionic. Next, sodium lauryl sulfate. Student, the 12 carbon chain is lauryl here. So this is the sodium and the lauryl and the sulfate. Again, we can see that the negative part is bonded by the carbon chain, because of that this is the anionic, not cationic. So only second option is going to be correct for you. Thank you.
Our question is, the freezing point depression constant Kf of benzene is 5.12 Kelvin kg per mole. The freezing point depression for the solution of molality 0.078 molal containing a non-electrolyte solute in benzene is. So student, we have to calculate the freezing point of depression, that is delta Tf. Students, we all know that the formula for delta Tf is, as this is a non-electrolyte, the formula will be, this will be equals to Kfm. Clear? The value of Kf has been given, this is a formula based question. The value of Kf has been given direct, that is 5.12, and molality has also been given, this is 0.078. So this will be equals to student 5.12, and I am rounding it off, it has 0.08. 5 4s are, this is 8 5s are 40, and this comes out to be equals to 0.4, something around 0.4. So the correct option will be, this is 0.4 Kelvin, that is delta Tf. So the freezing point depression for this will be equals to 0.4 Kelvin, that is option number 2. Clear?
Ishwan, this question is taken from the D block element chapter. So the question is asking that identify the incorrect statement, wrong statement. So first of all, the transition metals and their compounds are known for their catalytic activity due to their ability to adopt the multiple oxidation state. We may also call it the variable oxidation state to form here the complexes. Have a look, student. This is the reaction which we are observing in the contact chamber process of formation of sulfuric acid. So SO2 is oxidized by V2O5, vanadium pentaoxide catalyst, and SO2 is oxidizing into SO3. Here you can see that this V2O5 is having, vanadium is having the +5 oxidation state, and first of all this is oxidizing SO2 into SO3. This is the intermediate process, you can say the mechanism of catalyst, and this vanadium from +5 to going into, reducing into +4 here. So you can see that it is showing here the different kind of oxidation state. Now what will happen here? This oxygen will combine with this V2O4. Now it is oxidizing into V2O5. Again this V2O5 activates to oxidize SO2 into SO3. So we can see that the multiple oxidation states are shown by the D block element, transition element. Because of that, these are working as a good catalyst. This statement is true, but we want here the incorrect. This is the correct statement. So cross it. Next. Interstitial compounds are those that are formed when the small atoms like the hydrogen, carbon, nitrogen are trapped inside the crystal lattice of metals. When we have drawn here the crystal lattice of matter, in which this space is known as the interstitial space. Here the small size atom like the hydrogen, carbon and nitrogen, a small size atom, these are trapped, and now we are getting here the interstitial compound, in which you can say that the density is more, melting point is more. These are the chemically inert, these are the hard, but you can say that the metallic conductivity remain unchanged. But you can see that this statement is again going to be correct, but we want here what? Incorrect statement. Next, the oxidation state of the chromium in the chromate and dichromate are not the same state. Have a look. This is the chromate. Chromium X, 4 oxygen minus 8, single oxygen minus 2, 4 oxygen minus 8. Overall charge is what? The -2. So we are getting here the value of X +6. It means chromium is present in the +6 state. Next, Cr2O7 -2. You can see that the 2 chromium are present here. 7 2s are -14 is there. Overall -2 charge is present here. So the value of X we are getting here the +6. So student, you can see that both of these are showing here the same kind of oxidation state, but the statement is saying not same. It means this is going to be incorrect statement, but the option is correct here. Next, chromium D4 is stronger reducing agent as compared to Fe+2 in water here. Have a look here. Cr+2 after removal of electron is oxidizing into Cr+3. Similarly, Fe+2 is oxidizing into Fe+3 obviously after removal of electron. So chromium is oxidizing, similarly Fe is also oxidizing. Here the value of standard reduction potential is -0.41, while here the +0.77. It's lesser the value of standard reduction potential, more is the reducing power. So based on this value we can say yes, of course chromium is a strong reducing agent. This statement is correct, but we want here the incorrect statement. One more thing, this is converting into half-filled T2G configuration, while this is converting into D5 configuration. So the different kind of configuration we are observing here, and based on the SRP value we can say yes, this statement is correct here. Chromium +2 is strong reducing agent. So only incorrect statement is third, that is your answer. Thank you. This question is asking that which of the following is not correct, wrong statement about the carbon monoxide. This question is taken from the environmental chemistry chapter. And as far as the NCERT is concerned, you will get this at the page number 400, new NCERT. So first of all, it reduces the oxygen carrying ability of blood. We are talking about the carbon monoxide. Of course, hemoglobin is the oxygen carrier in our body, present in the blood. And as far as this hemoglobin is concerned, when exposure of carbon monoxide is there, it forms here the carboxy hemoglobin, that is a 300 times more stable as compared to oxyhemoglobin. So obviously we can say that it blocks here the capacity of hemoglobin to carry oxygen. So this is going to be true option here, but we want here the not correct. Next, the carboxy hemoglobin bound to CO is less stable. Student, this is the wrong word. If you are comparing here, this carboxy hemoglobin is 3 times more stable as compared to oxyhemoglobin. So yes, this is not correct. The option is going to be correct, but the statement is incorrect here. Next, it is produced due to incomplete combustion. We are talking about the carbon monoxide. So carbon can oxidize into CO and CO2. When complete combustion is there, then we will get here the CO2, while in case of insufficient combustion is there, incomplete combustion is there, we are getting here the carbon monoxide. Not only this carbon, we may have here the hydrocarbon also. Got it? So by incomplete combustion, we are getting here carbon monoxide. True statement. But we want here the not correct. Next, it forms carboxyhemoglobin. Of course, you can see that it is forming here the carboxyhemoglobin while combining with carbon monoxide, and hemoglobin is combining with CO. So all of these are the true, only incorrect statement is second here. That is your answer. Thank you.
A question is, hydrolysis of sucrose is given by the following reaction. That is, sucrose plus water gives glucose plus fructose. If the equilibrium constant Kc is 2 into 10 to the power of 13 at 300 Kelvin, the value of delta G at the same temperature will be. So we have to calculate, students, the value of delta G. This question is from the thermodynamics chapter, class 11. Students, we know that this is delta G naught. Sorry, this is delta G naught. We know that delta G is equals to delta G naught plus RT ln Q. If we are having the reaction at equilibrium, so at equilibrium delta G will be equals to 0 and Q will be equals to K. At equilibrium we say Q is equals to K. So the equation will be equals to 0 is equals to delta G naught plus RT ln K, or we can write it as delta G naught is equals to minus RT ln K. Clear? So the value of delta G naught from this will be equals to minus 8.314 into temperature has been given in the question, that is 300 Kelvin, into L into the value of K is 2 into 10 to the power of 13. The value of K has been given, that is 2 into 10 to the power of 13. This is 2 into 10 to the power of 13. Again, it is a formula based question, so the correct option will be minus 8.314 into 300 into ln 2 into 10 to the power of 13. So the correct option will be option number 4. Clear?
This question is taken from the coordination compound chapter. Got it? And the topic is spectrochemical series. One order is given here. As far as NCERT is concerned, student, you will get the answer at the page number 251 of old NCERT and 258 of the new NCERT. This is the order of, we can say that, strength of ligand or spectrochemical series. And you can see that the 4 ligands are given here, but the arrangement is different here. As far as thiocyanate is concerned, this is the first one. Next, we are having here the fluorido. You can see that the strength is increasing here. Next, oxalato. And finally, we are getting here the cyanido. So this is the perfect order: thiocyanato, fluorido, oxalato, and cyanido. 1, 2, 3, 4. So fourth option is going to be correct here. Rest of these are not possible. Thank you.
Okay, students, coming to the next question. Now the question is, identify compound X in the following sequence of the reaction. Now, toluene is reacted with Cl2 in the presence of light, means it is example of free radical substitution reaction. And we know that in case of free radical substitution, there is a possibility of mono substituted, dry substituted, tri substituted. 3 products can be found because there are only 3 hydrogen atoms. Means X can be monochloro product, means it can be benzyl chloride CH2Cl, or it can be CHCl2, and it can also be CCl3. Now X is hydrolyzed to give the product that is benzaldehyde. Now if we hydrolyze benzyl chloride, then this chlorine will replaced by OH to form benzyl alcohol. In second case, these 2 Cls are replaced by 2 OH groups, CH, OH, OH, and we know that gem diol is unstable. That's why it will eliminate a water molecule to form final product, that is CHO, benzaldehyde. In third case, if this will hydrolyze with water, then this carbon is having 3 OH groups, and we know that due to instability this will eliminate a water molecule to form a final product, that is benzoic acid. Now in this case the X will hydrolyze to give benzaldehyde, means X should be this one. So in this case the answer will be benzene CH2Cl2, that is second option. Clear?
Students, our question is the correct option for the free expansion of ideal gas under adiabatic condition is. This question is from the thermodynamics part of class 11th. Now student, we have been given free expansion, and for free expansion external pressure is equals to 0. If external pressure is student 0, work done is equals to minus P external delta V, minus P external delta V. If external pressure is 0, so work done will also be equals to 0. We have been given adiabatic condition. Adiabatic condition means Q is equals to 0. This means Q is equals to 0. Now Q is 0 and delta T is 0, so the correct option will obviously option number 4. Delta, if Q is 0 and W is 0, so the correct option will be option number 4. And now moving on to delta, how come delta T is 0? Now students, we know that delta T is equals to Q plus W. Delta is equals to Q plus W. If Q is 0, W is 0, the value of delta E will be 0. And if delta E is 0, the value of delta T will also be equals to 0, because delta E is equals to NCV delta T. So from here delta T will also be 0. So the correct option will be option number 4, that is delta T is equals to 0. Students, our question is the number of Faradays required to produce 20 gram of calcium from molten CaCl2. Student, this question is from electrochemistry class 12th. Clear? And we have to calculate the number of Faradays for to produce 20 grams of calcium. Now students, in CaCl2 the charge on calcium is +2, that means Ca2 plus will gain 2 electrons to give Ca, or we can say that 1 mole of cation will gain 2 moles of electron to produce 1 mole of atom. Students, 2 mole of electron means the charge is 2 Faraday. The charge is 2 Faraday. So for the deposition of 1 mole of atom, or 1 mole of atom, or we can say 40 gram of calcium, we need 2 Faraday of charge. For the deposition of 40 gram of calcium, or for the production of 40 gram of calcium, we need 2 Faraday of charge. So to produce 20 gram of calcium, the number of Faradays required will be obviously half of this. This will be equals to 1 Faraday. So the correct option will be answer number, that is 1 Faraday. Student, either you can do it by the unitary method, or we can also equate their gram equivalence. We have been given weight, so we can use W by E, and we have to calculate the number of Faradays required. So this will be equals to Q in Faraday. We are just equating the gram equivalence. So this will be the weight. The weight has been given. This is 20 gram, and equivalent weight of calcium is, student, again 20 grams. That is 40 by 2. This will be equals to 1. So 1 Faraday charge will be required. Either you can do it by this method, or you can do it by this method. Clear? So the correct answer is answer number 4, that is 1 Faraday. Clear?
Ishwan, this question is taken from the S block element, and the topic is sodium chloride, NaCl. And the question is asking that HCl was passed through a solution of the calcium chloride, magnesium chloride, and sodium chloride. Which of the following compound crystallizes? Ishwan, as far as the solution is concerned, in which calcium chloride, magnesium chloride, and sodium chloride are present, this is called here the brine, and this is having the impurity. Brine solution contains the impurity of sodium sulfate, calcium chloride, and the magnesium chloride as impurity. Ishwan, if you want to obtain here the pure NaCl, then we will pass here the HCl gas. If you want to obtain here the pure NaCl, then in this brine solution, which is containing here the impurity of these salts, we will pass here the HCl till solution becomes saturated. So we will get here the crystal of NaCl, while other salts, like according question magnesium chloride and the calcium chloride, remain in the solution. Why so? Because these are more soluble as compared to NaCl. These remain in the solution. Ashwan, this information you will get in the NCERT. As far as the old NCERT is concerned, the page number is 297, while in the new 305 is the page number. Thank you.
Okay students, coming to the next question. Anisole on cleavage with HI gives. Now, what is anisole? Anisole is PHOCS3, means methoxybenzene. If it is reacted with HI, then first of all, protonation will occur and form PH single bond OHCH3 and positive charge on this oxygen. In next step, I minus will attack according to SN2 mechanism, because for ether, if there is any 3 degree benzylic and allylic, then it will follow SN1 rule. But if nothing is present from them, then it will follow SN2. So in this case, there is phenyl and this is methyl, means no one is 3 degree benzylic or allylic. It means it will give SN2. So I minus will attack on less hindered side, that is CH3, because we know that any leaving group on unsaturated carbon cannot give neither SN1 nor SN2. So there is only one option for I minus to attack on this CH3 and break this bond to form the final product, that is phenol and methyl iodide. Clear? So in this case, answer is 4th. Clear? Okay students, coming to the next question. The question is, which of the following amine will give the carbyl amine test? Now what is carbyl amine test? Is a test of 1 degree amine RNS2 with chloroform in the presence of base to form a final product RNC, that is known as carbylamine or isocyanide. So this reaction is only given by 1 degree amine. So we have to find that which 1 degree amine is present from the options. First of all, in this case, this nitrogen is attached with 2 carbon atoms, means it is a 2 degree amine or secondary amine. In this case, nitrogen is attached with 3 carbon atom, means it is a 3 degree or tertiary amine. In this case, nitrogen is attached with 2 carbon atoms, then it is 2 degree amine. And in last one, nitrogen is attached with only 1 carbon. That's why it is 1 degree amine. So it will give carbyl amine reaction. So answer should be 4th. Clear?